This video is brought to you by Sporlan, quality, integrity, and tradition. So we got a call for a water leak, and they've got a giant pan down there because they say it's leaking water everywhere. So I open up this ice machine and I see water pouring out of the water pump. Might be hard to see, but it's literally just coming out the water pump and then just slowly running down the side of the pit. Then I look in here and the water's barely trickling out of the spray rails. Just barely. Like nothing. So let's turn this guy off. This guy over here, they're saying is not working. This one has a long harvest. So let's go ahead and clear the long harvest. There you go. Let's go ahead and restart this one. Service, real-time data, time and temp. And we'll watch this guy. So that's the sign of a bad probe. All the probes after it's been off should be relatively the same temperature. The T3 is bad, but it's just a supervisory thing, so it's not the end of the world. So we'll watch that make ice, and then this one right here, I'm gonna pull these spray rails. I bet you they're completely plugged up. Wow, those things are really difficult. So when you see that much calcium, usually it means that you have a bad dump valve. Usually it'll be full down in there too, and it looks pretty bad. However, see those little things? Yeah, those are maggots. Those are baby fly larvae. Fruit flies stuck in the machine. Yummy. That is dinner. But I bet you anything we're gonna have a bad dump valve. That or a plugged up drain line. But those are baby maggots. I'm gonna run cleaner through the machine right now, and we're gonna have to rinse it out again. But I mean, you can see these things shouldn't be all yellow and calcified. I'm hoping it's not a drain because I really don't want to redo drains today. The initial call today was actually on water leaking out there, which really leads me to think it's a drain issue. I've got my giant Granger, it's a 2R Victor Frank 7 fitting brush. It's like a 1-inch brush. Watch the poop stick that comes out of this thing right now. Look at that. That's a white brush, guys. Oh, look at that. That looks like dinner, right? Nice and yummy. Oh yeah, that's very appetizing, huh? I put it into a wash mode, and that's the purge valve back there. It's getting power because it's clicking on and off. So the next step is the dump valve itself or purge valve bad, or is the drain line plugged up? All we got to do is pull this rubber hose off back here. So yeah, if you come right here, when it was full of stuff, but when I turned it on, it's pouring water out now. Now granted, it's just a little bit because the machine doesn't have very much water in it, but if you ever see that much calcium in a machine, it's usually the leftover sediment. Every cycle this machine dumps out the water from the bottom of the sump, and it's just clogged up basically, and it's not dumping that sediment out. Got some of the Viper nickel safe ice machine cleaner from Refrigeration Technologies, poured it in there. The machine is in the fill cycle now, so it's not dumping water out the drain anymore, and it's just recirculating. So we're gonna let it break down a bunch of that gunk. Customer's gonna have to get rid of the ice, but I'll let them do that. And we're just letting it circulate at this point, letting it break down some of the stuff. Now this is just a quick clean because I'm gonna schedule to come back and do a super thorough clean, and then we'll have to fix that drain too. It's Friday at like 2 o'clock in the afternoon. I'm not about to start repiping a drain on one of these. It's just not happening today. They'll have to wait. These lines, so there's a tube that comes up and it goes right here, but before it does that, there's a T, and then it wraps around all the way to the other side. So if you look at this one's flowing water, and this one's not, because this one's plugged up with mud and stuff. So we gotta pull that hose apart just to get it working. Nasty. So I let it circulate. It only circulated on that side though, because this side's plugged, so we gotta go ahead and dump it. So I'm gonna just go ahead and dump it right down the drain. There's a pan down there to catch it. It's using the water pump to push. And then once it drains out, we'll pull the tubing apart and figure out where the restriction is. I don't know how I'm gonna get this thing back in here, but that's where there's a restriction right here. When I push the poop stick up, it pushed the stuff up into here. And it's hard to get it out, so I yanked this out. I'll tell you one thing. One of the dumbest things that Manitowoc ever did was put this barbed tee right here. This barbed tee gets plugged up itself if you don't run bleach through the machine periodically. Just a mess. But anyways, this hooks onto that barbed tee. You can see in there, everything's just nasty, so I gotta go wash this whole tube out. Well, I thought maybe it would start draining because I like pushed some stuff out of the drain, but no. It still doesn't drain, but at least we got water coming out that side now. I'm gonna run a little more cleaner through it, and then I gotta try to figure out if there's a way I can temporarily get that drain unplugged for the weekend. Life hack, pulled that hose, cut my fitting brush, put it in the drill, and ran it in and out, and then down the vent pipe for the drain, and I got it to drain. Sweet. Now we got cleaner running through it. It'll help to dissipate some of the calcium. And again, we're gonna come back and do this proper, but this is just to get me through the weekend. So this guy is the other machine, and it had a blown fuse. So I changed the fuse real quick because there was one spare left in there, but we got to figure out why. So I'm gonna open this up, see if there's anything obvious. Again, I'm not planning on spending a lifetime here, okay? I'm always about big picture, and I don't have the time to give them big picture right now. So it's a little picture kind of a day, so we can come back and give a big picture maybe on Monday, okay? And yes, I rhymed on that. So let's open this up, make sure there's nothing obvious causing the fuse to trip, and then we'll restart the machine and see if it'll run. Well, we made it through the weekend. This machine I had left off because the compressor was doing the fuses and thermal overload thing. This machine right here, doing the quick cleaning on it, got it running, and then I actually have a technician here now doing a full teardown on that machine. But it was full of ice Monday morning, so they're good. So we're doing a thorough cleaning on that. We'll run bleach through the machine and all that stuff. And then this one, I need to diagnose this compressor fully and figure out what's going on and why it was turning off on thermal overload. All right, I have a technician downstairs so I can have him turn everything on when I wanted to. Currently, the machine is turned off downstairs. I applied my service gauges. It is not R22 refrigerant, it's 404. We've got equalized pressures. I did another visual inspection on this guy. I don't see any burnt wires. The contact points look great. We've got a completely reset thermal overload on this compressor. So at this point, we're gonna turn this guy on and see what happens. Disconnect switch is going bad, so that's something we need to look into. But I mean, compressor's pumping down. Condenser fan motor's turning on. Compressor's running about 5 amps. Condenser fan motor is running about 1.08, and the condenser fan motor is allowed to run 1.3. I wrote it right there. So we're pumped down. So at this point, I need to have my technician downstairs go ahead and turn the machine on, and then that way I can watch the operation from up here and see what I see. Know what I mean, Vern? All right, the machine is back on. It looks like it's in a harvest. Oh no, there we go. Yeah, we'll see. But fan cycle control should turn it on here any second. Condenser fan motor should be turning on about 250. There you go, 260, that's close enough. Compressor is running, so let's go ahead and check current. About 6.5 amps. Now I don't know what RLA is on this compressor. 7.2 amps. That's interesting that we have such a higher number on the one leg, but I don't see anything jumping out at me yet, so we're just gonna watch this guy and see what happens, see if the compressor shuts off. I don't think this temperature right here is not accurate. That says 84. I'd say it's about 75 outside right now, entering air into the condenser. But so far, nothing too crazy. Just watching. It's got a cold suction line. Compressor's running its heart away. This disconnect switch doesn't look good. It's not making good contact. Right here, when I turned it on, it didn't turn on at first. So this is definitely something we're gonna consider replacing. So that'll be on the list. That could cause fuses to blow, but I don't know if that was our issue. We'll have to see. I need to measure some voltages now to make sure we're actually getting correct voltage. So coming out the bottom of the contactor, 1 to 3 is 207, 1 to 2 is 206, and 2 to 3 is 205. So we have three-phase voltage being delivered. We're frosting up like you should be. We're just gonna monitor this guy and see if we see anything going on. So I don't know why this guy would have shut off on thermal overload. Down on this data tag down here, it says compressor RLA is 7.7 amps, and we're at 7.3. That doesn't seem too bad. Nothing too crazy. If people see this, people may think like there's something wrong. There's actually nothing wrong, and this accumulator is doing everything it's supposed to be doing. So notice how one side's frosting, one side's not. What you're seeing is, you know, potential liquid refrigerant vapor with liquid mixed into it coming into the accumulator, but then you're seeing vapor going out of the accumulator. So it's not abnormal to see an accumulator frosting or to see, you know, a sweating line coming in and a frosting line going out. That doesn't mean there's anything wrong necessarily. Yeah, not looking bad. So we're just monitoring. Current's kind of where it should be. See if we can duplicate whatever this issue was. This guy is being a pain. It's not doing whatever it's doing. It's been running. It's about to make ice. So we're gonna watch it. I'm really suspecting this disconnect switch as being the problem. And while, like I said, when I turned it off then turned it back on, the machine didn't turn on. Then I slammed it down and pushed it up again, boom, and it engaged. So I'm thinking that the knives right there is the knife. And I'm thinking the knife isn't making good contact and can cause low voltage, high current, that kind of stuff. So yeah, we're just gonna watch it because I don't want to interrupt the cycle. Unfortunately, if you shut off this disconnect switch, it kills power to the transformer, which gives you a 60-minute delay on the machine. So we want to see it follow through with its ice making cycle. And then what I want to do is turn it off and turn it back on and see if I get a measured voltage drop when I don't really try to engage it. At least that's the thought. So if we look in here, that right fuse is not making a good connection. So when I turn it off, and then watch what happens when I turn it on. See, it took a second to engage, and it wasn't engaging very well. Okay, so power is off. Let's verify real quick before I stick my hands in there, because I'm about to grab a fuse. And let's go ground it. We're dead. Oh, I need to do this. First off, let's check. Dead. 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 And then we'll check to ground real quick. Dead. 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 Okay, so we're completely dead, so it's safe for me to grab. What I want to do is I want to see how difficult it is to get this top fuse out. It comes out pretty easy. And look at the inside of that guy. Looks like it's been overheating. Let's look at the inside of the other guys. Yeah, they're pretty hot too. Yeah. Pretty hot. But, oh man, that fuse is hot from the right side. The middle one is not as hot at all. Let's see what this one feels like. What's this guy? It's not as hot. So this one right here, which was the far right fuse, is smoking hot. Yeah, I don't like the look of that disconnect switch. So we are going to be replacing that. What I'm going to do temporarily is bend the fuse holder in, just to make it make a little bit better connection, because I'm going to have to go get a disconnect switch, and I can let the machine run while I'm doing that. So we'll get it right in here, bend that in just a little bit, so that way it's making a tighter connection on the fuse. Okay, we'll slap the fuse back in, turn it on, and I'm gonna go get a disconnect switch and we'll let it run while I'm doing that. And you see this time, it didn't even make a connection. Look at these guys. I'm using an insulated screwdriver. Look at, see that? That's what we're worried about. Those things are not pushing in. Now I am using an insulated driver, okay? But that's what I was afraid of. I'm wondering if when I got here the first time, if this wasn't making good contact and potentially causing low voltage to the compressor, which caused it to single phase. That's my thought. So I'm gonna go get a disconnect switch. All right, I've got the new disconnect installed. I went down to my van and I got my torque driver and I needed a wire nut for this ground wire, and I totally forgot to get new fuses, so I'll have to go down there. But I got a gripe, and that's these manufacturers putting torque specs, but then when you try to torque down to those torque specs, you strip out the screws. That's just silly. So this one says the torque specs are, where's it at? All right, the torque specs are 36 to 40, okay? So I set this guy to 38, right? And then if you notice, look at the screws, it's stripping the head of the screw. Now, I was able to get it torqued down, but I've been noticing that on some of these manufacturers. They give you these torque specs, and then when you try to do that, the silly aluminum screw that they're using to tighten down ends up breaking. And I'm using two hands. I'm not trying to do this because I didn't show you guys. I wasn't trying to film it, but like, yeah, see, like that one right there, I just kind of did it with my hands and it just twists off the top of the aluminum head. And I tried using a bigger bit and it, you know, whatever. But anyways, I got it torqued down, but it's just kind of silly that they put a torque spec on there, but yet their screw can't handle those torque specs. Go figure. Go figure. Would you just look at this, right? So I'm gonna go get 3 new fuses, throw them in there. We'll leave these 3 for spare because those are new fuses that I had put in the other day. And then we'll be ready to turn this guy on and then watch the operation. Got 3 spares for the next guy. Fuses are in, everything's torqued. We'll put the cover on, put the screws in here in just a second, but we can turn it on. And then just wait for my technician downstairs to go ahead and turn the machine on because I had him turn it off. Let's see what my gauges say. Yeah, see, it's still pumped down. So we need to turn it on downstairs and then we'll monitor the operations and watch it make a couple batches of ice. Well, that's just how my luck goes. I turned it on. I measured, I didn't get the camera on. I measured 3-phase voltage coming out of the contactor. We had 3-phase, 202, 3-phase going to the compressor. But one of the legs of the compressor was amping really high at 17 amps. And it just shut off on thermal overload again. Good grief, go figure, right? So, I know that there was something wrong with the disconnect. I know that it wasn't making a good connection. You could tell. But I'm wondering if it already damaged the compressor, like it's been going on and off on thermal overload for a long time. What's interesting is I watched it for a good hour before I replaced the disconnect and it was fine, running good amps and everything. But this time I turned it on, it was pumped down, it came on out of pump down, and instantly on this yellow wire right here, we were running 17 amps. And I measured 3-phase power. Now, unfortunately, I didn't measure at the compressor terminals because the type of plug they have, you can't measure while it's actually doing that. You can't see it. So you can only measure it at the contactor or pull the plug out and measure it at the plug itself. It's like a funky Molex plug, similar to what Copeland uses on their scroll compressors. Gosh darn it. That's frustrating, man. Yeah, this guy's off on thermal. It's really hot. Let's see if we can get this to happen again. So I'm gonna turn it on. I've got current on the yellow wire right down there, okay? And I'm gonna switch over the phases. So we're gonna measure this voltage right here first. I've got one leg already on the, there's that, okay? So let's see what this does. 1, 2, 3. Please don't blow up. Oh, it's 60-minute delay or whatever. There we go. All right, now it's running at 7 amps. Not bad. 202. Let's measure this one. 205. So we're running fine. Now, why was it measuring such high current? See, I think there's something intermittently getting stuck in that compressor. We're We're running 8 amps right now. Oh wait, why did we just lose current? Did we just go off on thermal? No, that's weird. Look at that. 15 amps, there it is. 206, 204. We have 3-phase, and it's doing it again. Yeah, we've got a bad compressor. This guy's not running. So I'm gonna pull the pigtail and just verify voltage at the pigtail. So one leg to one leg. Let's just call it line 1 to line 2. Let's call it line 2 to line 3. 3 to 1. So we have 3-phase going to the compressor, and intermittently the compressor is locking up. It's really interesting too, because I watched it run this morning. I watched it run 2 cycles. It ran fine, no high current. Made 2 batches of ice, and then I left, got a new disconnect, came back, and now it's locking up. It is just dead. So at this point, it's time to talk to the customer, let them know we need to get a new compressor for this guy, and go from there. And then my technician is just about done cleaning both the machines, so we're pretty much left down to that one. I'll go ahead and shut this one off. Sucks that I had to put a new disconnect on it, but it is what it is. So you know, we'll still talk to them about the compressor, so they'll end up getting that, and then, you know, we'll go from there. I think I said this recently in a video, but hats are back in stock. I ran out for a 2-week period or something like that, but we have plenty of small, well, we had plenty of small mediums, but the large, extra large, which is the most popular one, those are back in stock. So if you're interested supporting the channel, we have t-shirts, we have women's t-shirts. The flag shirt is the one that we have in the women's. It has the flag on the sleeve, and then it says HVACR videos on the back. But anyways, HVACRvideos.com is where you can pick all that stuff up. But yeah, anyways, so this was an interesting one, right? Okay, first and foremost, the machines were dirty, okay? They had the little flies inside of them. I've seen that before. It's not very, very common, but I have seen it before. It does happen every once in a while, okay? The solution, you just got to clean the machines. Try to clean them with bleach, run bleach through them, do all that good stuff. But I got the restaurant operational. They called me originally about water leaking. When I got there, I was like, oh man, I know what this problem is. And I kind of alluded to it in the video, but I don't think I explained it enough. What happened was the drain line coming out of the machine had a massive restriction in it for whatever reason, okay? There was chunks of stuff stuck in the drain line, and it wasn't letting the machine drain. So almost every ice machine out there that I know of does a purge cycle where it purges all the old water out of the machine and dumps it down the drain. Because the calcium doesn't refreeze, it doesn't do a good job, so it just gets stuck in the machine and just builds up and causes the machine to not work. So in this situation, the machine was trying to dump all the water, but it couldn't because the drain line was restricted. Now, we use copper drains on these things, and it's difficult to replace them, okay? I get a bunch of people asking me, why do I use copper drains? Because copper drains don't break, okay? Customers in these restaurants, they take squeegees, cleaning under the machines, and they break the PVC drain lines all the time, and then it's a pain in the butt to fix them. Especially, this machine is not as hard, but if you get to traditional bins, see this one, the bin is elevated like 3.5 feet off the ground so they can push a cart under it, but normal bins go all the way to the ground and there's only about 6 inches clearance underneath it. And if you have a bin that's, you know, 4 feet deep, there's nothing worse than having to try to reach your arm under there to fix a broken PVC drain line. It's a pain in the butt. So I always use copper. Plus copper lasts forever, okay? In weird situations like this, you get restrictions in it and stuff, but you know, you can usually, it doesn't happen very often, okay? But in this situation, we had a restricted drain line. It wasn't allowing the machine to drain, which was causing buildup in the machine, at least the right side machine. So what I ended up doing to solve that was, after I did a quick cleaning on the machine, I took that fitting brush and I ran it in and out like an auger in the drill and just pushed it in and out, and then went down. After I pushed all the stuff back into the drain, then I went down from the vent, because there's a T on the back of the machine, and pushed that thing up and down a bunch of times, just reversing and going forward with the drill. And I was able to break whatever was stuck in that drain line up, and it flushed down into the drain, into the floor sink basically, okay? And then I ran ice machine cleaner through it again and broke up even more. So that was the initial issue. They were just complaining about water leaking, but then I noticed that the left machine wasn't working. you know, did a quick clean, got them operational, then found the left machine was going off on overload on the roof. I didn't get a lot of footage the first time doing that, but when I went back, you guys saw the footage of me, you know, diagnosing a bad disconnect switch. Now, you know, sometimes you have to use the information you have, you know, and this one kind of stunk because, man, I couldn't figure out why the compressor was going off on overload, and initially I couldn't duplicate it again. Watched it make a couple batches of ice, everything seemed fine, but I was very suspect of that disconnect, and sometimes you just have to start with the known problems. Unfortunately, you know, for the customer, we had to put a disconnect switch on there, then to tell them that they had a bad compressor. But that's how it works, especially if you don't regularly maintain your equipment. Then you run into these kind of issues, okay? So when I turned that off, I could clearly feel that the disconnect was bad. You could just tell, you know, and then you guys saw how I showed in the video pushing the knives in, and disconnects are a big failure point. A really big failure point. Now, why do we use fused disconnects? Honestly, I don't like fused disconnects. I really don't, because if you have one fuse blow because a condenser fan motor failed, right, and just one fuse blows, that compressor theoretically could single phase, and then that could ruin the compressor if the thermal overload doesn't cut it out, okay? I prefer safety switches, non-fused switches, but the issue with safety switches is majority of the time the breakers downstairs are not sized properly, okay? They're usually much bigger than what the maximum fuse and or maximum circuit breaker size listed by the piece of equipment. So it's not very easy to just get a safety switch, because I'm not, you know, I'm not an electrician, so I'm not changing breakers on a regular, right? And getting the customer to do that, typically it's like pulling teeth out. It's a pain in the butt. So it's easier just to go back in with a disconnect switch, okay, with the fuse disconnect switch, because that's what was existing before. Put that in, and then sure enough, the compressor went off on thermal overload again. You know, I did everything that I could. I can only do so much, and I just follow the steps and work my way through it. But when you see a disconnect that bad, there's clearly a problem there. Now, I firmly believe that that disconnect switch caused the problem with the compressor. Okay, I really do. I think that it was making bad connection for a long time, causing maybe low voltage issues, and it caused, you know, the compressor eventually to fail, right? That is a Bristol compressor. You can't get that compressor anymore. It's going to be a changeover to a Copeland recip, and honestly, those compressors from the factory are stupid expensive. Now, I can go, you know, figure out what the number is for the compressor, then go to my supplier and buy an aftermarket compressor, and it would still be the same compressor. Most likely. You do have to be careful, because sometimes manufacturers do get custom stuff made for them, but more than likely I could find that compressor locally. But usually on the compressor model numbers, on the last three of a Copeland compressor, it usually says like 100 or 110 or 112 or something like that. And that's usually a code designating that it's an OEM compressor. And when they're OEM compressors, there's usually some funky things about them. Usually it has to do with the piping configuration. Maybe instead of coming out the compressor and going straight up, they custom order a compressor where it comes out and goes to the side. These are all things that could be remedied with some piping, right? I could use an aftermarket one, but also, if I buy that compressor from Manitowoc, which I would do that in this situation. If the customer wants to do it, we're going to go ahead and get it from Manitowoc. Even though they're ridiculously expensive, they come as a kit. It usually has the piping set up to where I don't have to be getting in there with benders or anything like that, and you literally just plug and play their piping, boom, 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 erector set it together, braze it up, and call it a day. So for me, the ease of using the OEM parts far outweighs the cost. It just makes it easier, okay? And it just makes things go smoother. I really think that they would be in their best interest if they replace these ice machines, because they are older machines and they're going to be running into problems in the future. But that is not my decision to make. This particular customer buys their own ice machines, and I just give them suggestions of when it's time to replace and what parts it needs, and they choose to have me repair or replace the machines. Now it's really difficult to get ice machines right now, so you know, who knows. But again, that's in the customer's hands, okay? I did everything I could. I did my best, right? I did a quick cleaning on the right side machine, got it operational through the weekend, got the drain cleared on it. Then I had a technician come back on Monday. We thoroughly broke down the machines, got rid of all the ice, cleaned them with ice machine cleaner, then very carefully rinsed them several times. Then We went ahead and ran bleach through the machines. Again, you need to be very, very careful. And I can't stress this enough. Do not mix bleach and ice machine cleaner. Do not. Okay? Very, very bad results can happen. Very deadly results can happen. So you want to be very careful about that. I once had a situation where I cleaned an ice machine. Okay? It was a Hoshizaki ice machine. So I was cleaning using the clear ice machine cleaner, the pure phosphoric acid. Okay? And I was cleaning an ice machine. I cleaned it. Everything was good. And I went and rinsed the machine, drained it, and then went to go sanitize it. And I was going to use bleach to sanitize the machine. Okay? It's very common to use bleach, especially in the old days on ice machines. And when you have one as dirty as these ones were, you got to run some bleach through it because that stuff is not getting taken out with just ice machine sanitizer, okay? But anyways, follow all instructions, be very careful, make sure you sanitize it appropriately after that. But anyways, back to my story. Cleaned an ice machine with ice machine cleaner, dumped it all down the drain, rinsed it, ran water through it, dumped it all down the drain. Then I ran bleach through the machine, okay? What happened was when that dumped down the drain, there was still ice machine cleaner in, I'm assuming, the P-traps. Okay, the bleach mixed with it, and I kid you not, there was, the best way I could describe it is mustard gas, okay, because it was phosphoric acid and bleach mixed together, and there was toxic gas coming out of every floor drain in that kitchen. Luckily, nobody was in the building as far as customers go yet, and the exhaust fans were running. But I noticed it really quick. Standing by the ice machine, you take a breath, and all of a sudden you can't breathe anymore because it displaces the oxygen, and it's just horrible feeling. And you're like, oh my gosh, what do I do, you know? And so I quickly ran around the building, opened up all the doors. The exhaust fans were already running. I started pouring water down the drain, flushing it out. And luckily nobody was hurt. I don't even think the customer realized what happened, but I just propped every door open because I knew that was bad. And I mean, in all honesty, I followed the proper procedures, right? I ran water down the drain before I poured bleach in there, then the bleach, but somehow it still mixed in the floor drains, and it was coming up the floor drains everywhere. It was bad. It was scary, okay? So do not mix ice machine cleaner and bleach. Trust me, because that could have been deadly. That could have been bad. Imagine if they had customers in the building. I mean, they could have evacuated the building. Like, oh my gosh, that's so scary. So be very, very cautious when you're working around chemicals. Always understand what bad things can happen. We are not chemists whatsoever, so be very cautious, especially when you're using bleach in restaurants, okay? Now, if you're an ice machine tech, you probably know the need for bleach in certain situations because, you know, they make ice machine food grade approved sanitizers and different things to run through the machines. But when these customers don't maintain their equipment and it's full of slime, that sanitizer doesn't do anything to break up that slime. And sometimes the only thing you can do is use bleach. But man, I don't even let my employees use bleach. Like it's only me, and it's only very calculated and very, very careful. So, you know, you got to make sure. So when my guy was cleaning the machines, I went down and made sure we rinsed everything, flushed everything. Then we administered bleach, watched it run. But you just got to be so careful. So trust me, don't mix those cleaners. It can be a bad situation. Okay. So we got this customer going as best as we could, you know, and just be, it stinks that we weren't able to fix it, but sometimes this stuff happens, you know? And I thought about this when I was thinking about this video. I'm like, man, do I really want to put this out there? But you know what? They're not always home runs. You know, sometimes we run into these issues, and you know, it is what it is. All right. I really appreciate you guys making it to the end as usual. Thank you so very much for all the support that you all give to the channel. It's amazing, the comments and the feedback that I hear from all of you. It is so humbling. It is so awesome. Still don't even get it. I still don't understand it because I'm just a service technician. I don't see myself as anything special. I'm just a normal dude that just happens to turn on a camera and film what I do on a daily. And to get all the support and the comments and everything I get from you guys is so very humbling. So thank you so very much from the bottom of my heart. I really do appreciate you all. Remember, please be kind to one another. There's a lot of craziness out there. And I'm just over all the hate and animosity. It is okay for you and I to have different opinions.
That is why we live in a free country. So please understand that and remember that. It's okay if I think something different than you, and it's okay if you think something different than me. We don't have to hate each other for it, okay? We could still coexist. We really could, right? So thank you so very much, and we will catch you on the next one, okay?